Welcome to another SRC coil selection walkthrough. My name's Will Click. I'm a sales application engineer here at SRC's Richmond division. In today's video, we're going to show you the best practices for designing a heat pump coil at Enterprise, SRC's coil selection software. So we're going to start by creating the project profile in your Enterprise software. So with that, just fill out the basic information at the top like you would any normal selection. However, we're going to call it indoor coil because it will be operating both as an evaporator and a condenser at different points. So we'll start with indoor coil cooling mode. From there, we'll go over and enter your thermal properties. Generally, you're going to have a wet air stream since you're going to be trying to get moisture out of it on the evaporator side. So we'll start with a 2400 CFM, which is just a plug number. You'll enter your own information for that. 8067 is the conditions that we chose for this. Generally, that can be any type of return air temperature that you're seeing in the space. 80 is probably on the high side for most comfort cooling. From there, we're trying to get the capacity down to where your leaving air is around 55 degrees. That way you should be getting good condensing on your evaporator coil and raining most of that moisture out of the space. After that, we'll select our refrigerant, in this case our 410A, which is the most common that we're still seeing today. Refrigerant temperatures, again, you should have that based on your system, but for a baseline, we're going with 45-110 Fahrenheit. And then we'll be doing our tube size. The 3/8 tube is our starting point. That's a good baseline, and you can refine from there, unless you're doing a particularly small or large system. Airflow, again, we're going with, and we'll go with copper tube. Rifle tubing is usually where I like to start. It gives you a little bit better performance. The aluminum fin, 0055, and corrugated is again a good starting point, and we can refine from there. Our size I'm going to be going with on this selection is 24x24. If you can stretch your coil out a little bit more to have a longer fin length, that's generally the better ratio for cost effectiveness. And then fins per inch, 10 fins per inch is just a good standard baseline that we can start and increase from based on our conditions. For circuitry, we like to start with full circuit again, just for a good baseline. As you can see, once we get all this entered, we're a little bit low on our capacity at only 60,000. So we're going to change down to a half circuit to increase our refrigerant pressure drop, but gets us a little better performance. Again, this is still all how you would normally select an evaporator at this point. Doing a little bit more refinement on the circuits. So we're getting it down to 6 circuits. However, now we can see that our refrigerant pressure drop is substantially higher, so we'll have to go with an 8 circuit. And increase our fins per inch a little to try to get that capacity up. We're a little higher than we normally see on the air side pressure drop, but not excessive. Make sure you save that. And then we're going to go over to copy the coil. So just go to Coil, Save As, and we'll create the same coil in heating mode, but we'll have to change it to a condenser coil. Again, you'll go back through, you'll have to re-enter all the information from before. It should still be the same for the air flows. Your temperature is obviously going to change with that. So we'll go on the lower side of your entering air temperature range. So I like to go through and copy my other coil from before just so that I can make sure I match up all of the conditions. So I'll do a screenshot of it. Again, we've got to go back, enter your 410A. Our condensing temperatures and hot gas temperature will be varying based on your system. However, the 117, 193 Fahrenheit is a good starting point. Now we'll need to recreate the same coil. Make sure that you line up all of the properties exactly. You don't want to design an evaporator that's 0055 and a condenser that's 0075 that's supposed to be operating the exact same. So once we get all of those entered back in, we'll see that your performance comes out. See, we're a little better on our refrigerant pressure drop, and our capacity is right at where we want it to be. So this looks like it's a pretty good setup for this one. So now we're going to go back to our thermal properties. Just check, make sure everything's still aligned. Since we've got a little extra on it, we're going to, a little lower than where we'd like to be, we're going to play with our condensing temperature some, bring it down until we get it lined up exactly at those conditions so you can kind of see where your minimum condensing temperature can be at. So in this case, it's 115 will get us right where we want to be. And now you can base the rest of your system on that as well. So next we're going to have to create the outdoor coil. So to start with, we're going to be creating that as a condenser coil. We'll call it outdoor in cooling mode, since that's its primary operation is cooling mode, so it's condenser. Our airflow is going to be substantially higher on that unit typically. We don't really care about condensate blow off everything since it's outside, so we can handle that additional airflow and higher friction or higher face velocity. The capacity, we're going to line that up similar to what we had seen previously. We usually like to have our capacity at least 15% higher on the condenser to make sure that we are fully condensing and meeting your indoor capacities. So again, we'll start with 3/8 tube. Go a little bit longer, and we'll do a little higher or lower fin density. Start out with just those 10 fins per inch. We'll go with corrugated again to start with. We can always up that to sine wave or lower it down to flat if need be. And we'll keep the same fin height to start. Your system will dictate that. For the fins, since we're outside, again, we don't have the concerns as much with the blow off on the coils and everything, so we can go a little higher fin density. We'll start off with that full circuit, and the system will automatically size your headers. So as you can see, we're a little bit light on capacity. Since we've got a pretty substantial miss on this one, we're going to adjust the circuit since it's so low. And then we're also going to adjust a few of the other parameters to try to make sure we can get it back up there. Looks like we're able to match it with just the circuits. So now we're going to save it again, just like we did before, and make it a outdoor coil. As you can see, I just did a screen grab of it to make sure I could copy it exactly. We're going to change it to an evaporator to operate in evaporator mode and as your heat pump. So be outdoor during the winter time, so you're going to have fairly dried air, so you're not concerned about wet conditions. Airflow, again, you want to make sure you match all of the conditions from the previous one. 4500 CFM, entering air 47, since you'll be operating in colder conditions. Again, depending on your climate and where it's operating, you're probably going to want to run it a little bit lower than 47 potentially. And as you can see, we've got the errors coming up, so we're going to go back, see what it is. It's saying that we're exceeding the possibility. So what we're going to have to do with that is go through and figure out where that issue is coming from. Most likely we're going to have to raise our liquid temperature slightly. So as you can see, we're looking through, we're going to have to up it to 108 right now and change our circuitry some. So once we did that, we're able to get our performance to come through on it. Now, again, we'll have to change circuitry again to match on the other coil. That's the big key. Whenever you change one on the indoor coil versus the outdoor, or the heating mode versus the cooling mode, you've got to make sure the coils match. So if you have any variation, you need to edit the other. You can see now we're missing on this coil, so we're going to have to adjust that circuit until we can line up both. Just everything in heat transfer is a balancing act, so you've got to make sure it all works. So now we're going to a sine wave, it's a little more aggressive fin pattern. It means your fouling is going to be a little tougher, but you're going to be able to get more performance out of it. And our pressure drop is still only at 0.49, so that's well within normal considerations. We'll up this back to a half circuit, 13 fins per inch, sine wave to match, and as you can see, we hit our performance parameters. So we're able to still get where we need to be, even with the changes.
That's going to do it for today's video. If you're designing coils for heat pumps and looking for an expert partner to help get the most out of your unit, visit our website or give us a call today. Thanks for watching, and we'll see you next time.